Alrighty, so, okay, this is going to be the last video before we take a quiz. Just to let you know, we won't have a quiz at the end of this week, but we will have a quiz at the end of next week unless something crazy happens. So, we are in 1.4, which is the distributive property, and we have used this property before. We've talked about it, so this shouldn't be too new because we have done that. There are some other vocabulary words, but overall, it's on the distributive property. So, getting started here. With the distributive property, there's two ways to kind of use the distributive property, especially if you're given just a list of numbers versus some variables in with it. So, when we're evaluating an expression, just a little reminder, we're ultimately going to get a single number as an answer. So if I said to evaluate this, so 420, 1 plus 1/2, and I'm not sure why my iPad's jumping today, plus 1, plus 2, plus 2 and 1/2. We could do this one of two ways. We could add all of the inside of the parentheses, so using PEMDAS, and that would give us 7 on the inside, and then we have 420. Remember, whenever we have parentheses with nothing in between it, so notice in here, let me pull out a highlighter so that way we're all looking at the same thing. In this area right here, there's no operation. We don't have a plus sign, a minus sign, or anything like that. So we're going to assume that we're multiplying. Just gonna write it. I actually wrote multiplication, so we don't think that's. So we're gonna do 420 times 7, which gives us 2,940. We could have also done this, so that's way number 1. Is if I have that 420 and then I have 1 plus 2 plus 2 and 1/2, I could distribute, and remember that word distribute means that I take whatever is on the outside being multiplied and multiply it by everything on the inside. So I'd have 1 times 420 plus 1 over 2, 1 and 1/2 times 420 plus 1, 420 plus 2, 420 plus 2 and 1/2, 420. So notice that everything on the inside, and I'm going to go ahead and grab my highlighter here. So my 1, then the 1/2, 1, 2, and 2 and 1/2 are all on the outside. And that 420, I took and I multiplied it by absolutely everything that was on the inside. I didn't just put it to the first term, I put it to absolutely everything, which would give me 420 plus 210 plus 420 plus 840 plus 1,050. And that would give me that same answer of 2,940 when I add all those numbers together. So either one of these ways works when you are evaluating, when you're doing, when you're finding a single number answer. However, sometimes we're not always going to have that. So if we're talking about the distributive property in general, what we have is something like A, B plus C, and this is just an example with variables, and it could be also minus, plus, or minus C. What that could be is A, B, plus or minus A, C. And that could also be written as B plus or minus C with the A on the other side. Either way, it still means that you're going to distribute whatever is there. So that is overall the distributive property. You are going to want to write this down. That is super important. So we did some examples before because that's what we did with way 1 and way 2. That was just kind of a reminder of how to use the distributive property. Let me see here. You could also go backwards with it. And if I had AB plus or minus AC, A is common between those two things, so we could go backwards and pull that A out. So for an example of going backwards, since we did one going forwards, if I had something like 7 times 49, that would be the same thing as saying something like 7. I'm leaving that first one alone, so 7 stays. And then I'm using 50 minus 1. It would give me the same thing because 50 minus 1 does give me 49. And I could use either method that we used at the very beginning of the video to go backwards. So either way works. We do use distributive property a lot when it comes to some word problems, and as you know, I like word problems. I like giving them to you because they're very applicable to how we use these things in real life, how we actually see these things being used. So for an example, if there was a group of 7 adults, so I'm going to write 7 adults, and 6 children going to the University of South Florida Bulls game. So 6 students going to a baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. And a adult ticket is worth $5. And a children's ticket is worth $3. And then if we have groups of 10 or more, tickets are $2 a piece. And if you're a senior, it's $3. So that would be over 60. So I know that I have 7 adults and 6 students. So I know that together the people going is 7 plus 6. So 7 adults, 6 students, 6 children, either way that you want to say that. And so 7 plus 6 is going to give me more than 10. So I know that I have a group rate of $2 a ticket. So everybody together is $2. So that's kind of how you can set this up. Again, then you can go back to the very beginning and use either the first way or the second way to solve this. You could do 7 plus 6, or you can distribute that in and do 7 times 2 and 6 times 2 and then add them together to find this solution. So I think it's a little simpler just to distribute in. Again, you could use just straight PEMDAS if that is helpful to you instead of doing this. So I'd have 7 times 2 plus 6 times 2, and that would give me 14 plus 12, which is in fact 26. Or I could have done 7 plus 6 first, which would give me 13. And that's still times 2, which again is 26. So either way, it still gives you the same answer. Just a little reminder there. So sometimes though we aren't going to be so lucky and we're going to be given variables, and I know how much we love variables, so we are going to go over an example using some of those variables. So first one could be 7 and then 3w minus 5. So in this case, I can't do anything inside the parentheses, and I'm just evaluating this and rewriting it so it's completely simplified. So in other words, there's no parentheses, anything like that. So when I'm doing this, I look inside my parentheses. So if I start with PEMDAS, I can't do anything inside my parentheses because of that W there, because I have a variable. So instead of just doing what's inside the parentheses, I'm going to skip straight to distribution. So I'm going to do 7 times 3, which is 21, and I have a W there, so I'm just going to leave it on there. And then 7 times 5, which is 35. From here, I look and I say, okay, can I put 21W and 35 together? And in fact, I can't, because remember, I don't want to put my peanut butter M&Ms and my Skittles on the same bowl, or my M&Ms and Skittles in general in the same bowl. I want to keep them separated from each other, so I'm going to leave them exactly how it is. And that is going to be where we stop there. But sometimes we may even have 3 terms. So maybe we have something like 6v squared plus v minus 3. We've got a 4 on the outside. So this time I have it written backwards than maybe what you're used to, but if I still have that number right outside of the parentheses, I can still distribute in. It's just backwards than what you think. So I could say the same thing, that these would be equal to each other. So I could say that 4 times 6v squared plus v minus 3 is exactly the same thing as saying 6v squared plus v minus 3 in parentheses times 4. Both of those mean the same thing. You're going to do the same thing. You're still going to distribute because I have those variables. It's just in a different order. We used that commutative property there. So I'm going to do 6 times 4. And that is going to give me 24, and I'll even write this out. So I do 4, and then 6v squared plus 4 times v minus 3 times, oops, sorry, I went backwards from how I was writing it. And then 4, and then 3. So I just brought, so my 6v was positive, so I left it positive. V is positive, so I have that positive out front, and then I have that minus sign in front of my 3, so I put it there as well. So I'm going to simplify then, and 6 times 4 is 24, and I'm going to leave that v squared on there, 4v, and then 4 times 3 is 12. And I can't do anything else with this because it's as simplified as it can get. I can't put v squareds with v's together because they're not like terms. So remember a few vocabulary words here. So like terms, those have the same variable and they have the same exponent. So same variable and same exponent, or the same power. So if I was to give you something like 6a squared and a squared, those could be put together because those are considered like terms. But if I gave you something like 5x squared plus 2x, those are not like terms, because they have different powers, but they do, since they have the same variable, we're almost there, but they don't have the same power. So both things need to be the same. So remember as well, a term is separated by adding or subtracting. I'll write plus or minus. So if I gave you something like 5x squared plus 2x plus 3, there are in fact 3 terms here. I have 1, and then I have that plus sign, so I have 2, and then I have another plus sign, so there is my 3. So that would be 3 terms. All right, and then last but not least, I think this is the last vocabulary term. I might give you one more just so that as a reminder of what some stuff is. So then we also have the simplest form. And just remember, simplest form is going to be when it contains no like terms or parentheses. So for an example, the simplest form in our examples earlier were, let me pull out a highlighter rather than that, were these red answers. And it's because there's no like terms, we can't simplify it anymore. We're without any parentheses. So we were good to go there. So that is considered what simplest form is. Then I think we have, let's see here, one more vocabulary word. And then remember to look over those properties of numbers that we did last week, because they do come back into play, and they will throughout the rest of the year as well. So maybe there's 2 more terms, but coefficient. And I know that we talked about this in here. Remember, a coefficient is the number with a variable. So for example, 5x squared, the coefficient of 5. And then our constant is a number with no variable. So if I had 5x squared plus 3, that has a constant of 3, because that 3 is without a variable. There's no x, y, z, or any other letter on with it. So finally, back to those changing expressions, verbal expressions to words. So back to 1-1. Yes, everything connects to each other. If I gave you something like twice the difference of 3x and y, what you're doing here is you're thinking, okay, difference means subtraction. So I'm taking 3x minus y, and twice means 2 times. So my answer then is going to be 2 times whatever the difference is. So I'm going to do twice whatever this difference is, which is 3x minus y. So, like normal, I'm going to give you 3 problems to do on your own and try them out. And I'm going to not pull up my keyboard. So, problem number 1 is going to be to use the distributive property and simplify. And for that first one, we're going to do 2g squared plus 9g minus 3 all times 6. And our second one is going to be 4 times the sum of 2x and 6. And you're going to write the verbal expression into a numerical. And finally, you're going to do, let's see here. Okay, so a pilot at an air show charges $55 per passenger. If 12 adults and 15 children ride in one day, write and evaluate an expression to describe. So we have 12 adults and 15 children. And that's very much like the very first example that we did together. So there's your 3 problems. Try your best, write in, and then at the very end of the video, don't forget to keep watching because there's a question about how you feel about everything. So again, like I said, this is the last video before we take a quiz over everything. So we'll have a break from these videos this coming Monday. So not this Monday, obviously, because you're watching this, but the following one.